Thank you, everyone, for amazing presentations. I really enjoyed watching how that common center of integrated process and information-driven approaches emerged. I will ask you to turn on your videos now for the discussion. But before we start our discussion, I'd like to invite all participants who are participating through YouTube to submit their questions in the YouTube chat, and we will read them to the panelists for you. Don't hesitate to share your comments and remarks in the chat as well. Okay, let's start the question. So I'd like to, first one I'd like to ask to everyone, starting with Brady and then moving in the order of presenting. If our objective was to build buildings in such a way that it's not only neutral for the environment, but positive for the environment, for the people, and if we assumed that we had unlimited resources, how would we measure success? What would our key results be? Brady?
Okay, great. I just get thrown in first here. What would our key results be? That's a good question, right? So I think, this is like one of these things, where you should ask for, we're like doing these things so incrementally. I think sometimes it's like we can lose the picture of like the big picture. And so I think that having an end goal obviously is like super important to know like where we want to be. And I think that obviously where we want to be is like to have buildings that not only perform well, but that people love, right? And I think that we have to like sort of incorporate both architectural dimensions as well as like engineering and performative dimensions to the work. And so not all of it necessarily is measurable in that way, but buildings that actually stand the test of time. And, I think like it's a bit, I think we all want to succeed, right? We all want this to succeed. When I showed that picture of Earthrise, and I think this community, we're a little bit preaching to the converted here. We're all designers of buildings, of the environment, and we obviously all want that very much to succeed. And where am I going with this? And so I think it's in a way, it's like not us that need to be convinced of this, So I don't know what those metrics should be to sort of convince the rest of the world to be able to take on these types of approaches, other than this is like absolutely crucial. That being said, like from where I'm sitting, like in the design technology end, there's still work that needs to be done. If we were to say overnight, okay, yes, go ahead, achieve it, give you all the money and materials in the world, I think we still wouldn't know exactly where to go. So I think that it's going to require studying buildings in use to get that feedback, to make sure that we in fact are doing what we want to do. We talked a lot about simulation today. And simulation is great that it's a predictor, but it's not the actual thing, right? So that those models that we're using are wrong, as was mentioned. So we need to like look at that with these sort of post-occupancy studies to actually understand what that performance is. Okay, I'll leave it there. Next person.
Yeah, I like it. Terry, would you want to now give it a try?
I think like kind of building on what Brady said, like that we're designing buildings worth renovating. We looked at some of the statistics and the things that we know already, that it's much easier to make these big design decisions for sustainability at the beginning of a process, and super hard to renovate certain things at the end. So if we design things properly at the beginning, that's obviously the way forward. So I think designing buildings worth renovating. And then if we were thinking about, I think like actually asking people there's a huge lack of that, of actually properly doing pre and post occupancy studies, asking people how their experience of the building is, and building that work into a contract, making that someone's responsibility. Because right now everyone wishes someone would do a post occupancy evaluation, but I mean, who's going to do that and share it and communicate it? So that's what I would say.
Great. Yeah, thank you. Kristen?
Yeah, I mean, so in this hypothetical where with our infinite budget and we've just achieved a net positive building, yeah, I think, I think it really does start to come back to those human aspects, in the sense that, that this energy and carbon discussion is very arithmetic in a lot of ways. If you get to the zero sum game and it's actually been established, then, yay for you, gold star for everyone. But then it really starts becoming, to Terry's last point, looking into realized performance. What is actually happening in these buildings? Are we achieving the results that we're looking for? And I think even sort of like looking back at, I think it was the third or fourth point of Terry's presentation, is that all of a sudden the human aspects just become really accelerated to where they should have been all along as being the most important thing. Is it, and then, for this hypothetical, Patrick, if we're able to do this with no budgetary constraint ever, then aspects of success are like global human happiness in the workforce and whatnot. Like, has absenteeism just been sort of eliminated as a cost to the white collar business environment? Just things like that as you sort of like focusing only on energy is annoying. It's far nicer to focus on so that you don't really feel the EUI of a space when you're in it, but you can definitely feel the space has been really well designed and optimized for human occupancy. So I think it's really that sort of shift that will happen if and when that hypothetical is achieved.
Okay, great. Thank you. Shada?
I'd like to echo Terry's point on designing buildings that can last, they're worthy of being renovated. I think the ultimate goal would be not just reducing carbon, but just reducing waste. Going back to an ecological system where we limit our construction waste. Like it's a huge problem that we're not even talking about as much as we should, because we're so concerned because of energy use and the problem that we're dealing with right now. But 50 years down the road, we're going to be faced with a lot of embodied carbon that we then don't know what to do with. So designing for disassembly, designing for adaptability, designing out waste in construction. Modular construction has a lot of benefits in that way. That can, it kind of fits into that circle. So it's a good thing, but there are a lot of different aspects that can also be considered, like what materials we use, how they're processed and all that. So I think reducing construction waste, keeping buildings in a loop longer are all really helpful.
Patrick and Nick?
I'll start off first. Yeah, can you imagine the creativity in the world if we all believed that things were unlimited creativity? It'd be a pretty amazing world to live in when none of us had self-imposed limitations on our own creativity. But so the reality is that that's not the case, and we are constructing buildings today with limited resources, and primarily the reason why we've chose to build in wood, because it's a renewable resource. And so that's the premise of all of we do. And if we continue to manage our forests properly, and as we do in Canada, the United States, and Europe, and other places, then are we able to build infinitely with wood? Very likely, as long as we manage that correctly. So it's a choice between using resources that are limited and those that are renewable. And that seems to be the smart way forward, I think.
Great, thank you.
Great. Great presentations, thank you. I wanted to talk a little bit about the technology, the tools that we have, and Brady, your comment about the constellation of design tech, and Terry, your illustration of how many tools we have available to us right now, not just for design, but for sustainable analysis. But it seems that over the years, we still see a lot of companies making their own proprietary tools. Do we as an industry really have the technology that we need, the tools that we need, not only in design, but in construction and operations to significantly improve building performance? And if we don't, what's missing? I think I'm going to start with Tristan, since you showcased your own in-house tools.
Yeah. I mean, I think the necessary ingredients are there in terms of, are all the tools necessary out there in the marketplace? In the sense that at my desk, which is becoming a distant memory these days, I've got just a printout that I sort of tacked up, that it was a screen grab from a presentation that somebody made that was just, talking about energy modeling and building simulation. And it's a representation of all the physical processes that are going on in a simulation. And it's like a mimeograph. The physics of what's going on in these spaces is not new. So in a lot of sense, the design engines that are in place are the necessary ingredients. Where the custom tool development, I think, tends to come in is that, it's come up a few times, buildings are annoyingly bespoke a lot of the time. Actually, not necessarily annoyingly, because that's what makes it really interesting too. We're an industry that's almost perpetually making prototypes. So in that sense, the custom tool landscape, I don't think is as much an illustration of, an absence of the right tools being available off the shelf. It's just more that it's kind of like off the shelf is the first 80% of the way there. And then we need to sort of throw in some customization, as it arises in our practice from project to project.
Mm-hmm. Is that what you found from your research on community, the environment?
Hey, Claudia, are you speaking to me?
Yes, or Terry.
Okay.
It came up a lot, the 147 environmental tools, and, the idea that again and again, we see companies continuing to make up their own bespoke tools. And so wondering if that's kind of the future, that will always be creating, also making tools, not just creating the architecture or doing the design.
Great question. And I think if we just sort of look at like a bigger picture, it seems like every generation, like in computation in the building industry, thinks they almost have it cracked, right? But then the next generation comes on and thinks, wow, these guys really didn't have it, and they're developing it more. So I think I think one of the points is that it's constantly changing, and that sometimes within like this 5-year period that we are sort of looking at, we see some sort of stability. I mean, Tristan is correct to sort of say like that the underlying physics for a lot of these problems remain relatively static, and in my own area of like acoustic performance, like the algorithms are sort of all there, and we can see like all the bits and pieces on the floor. It's just that we're still assembling it in the right way. But I think it would be wrong to sort of say that that all the tools are there. And I think that's one of the reasons why we customize. So, like when I was at the SMG in the early 2000s, there wasn't the tools, but there was the aspirations. So we had to like make the tools to be able to do what we wanted to do. And some of it was off the shelf and a lot of it was customization. And I think that our aspirations are just so much greater than the tools. And I think we're also like in this point of like excitement about using computation, right? So like if we think about like the drafting boards and slide rules and so forth, there's only like so much that we could do with them in sort of tool development. But as Patrick was sort of saying in his intro to this whole discussion, this notion of computation, which is sort of like underlying a lot of what we're talking about today, is really like changed the game. And so we're still realizing the potentials there. And I think we've really only just scratched the surface of what we're going to be able to do with that. I think we're making great progress, and it's so like awesome that we're all doing this and that we're all so excited about it. But I think that we've still got like a long way to go. And it's just going to be an exciting journey.
Yeah, and I think just to quickly interrupt here, and to kind of add to what you said, when we look at Gaudi and his analog parametric computer, how he kind of like connected elements and created relationships. It's not a task for just one tool or one software, right? It's a task for the creator, right? And so in that sense, we have a long way to go, I think, and it's unlimited, even like the potential of the creativity of the human mind, right? I don't want to be too philosophical.
Yeah, and just to sort of like again echo Tristan's point, which about like this bespokeness of all buildings, and that's something like when we're sold like the singular CAD system from the software vendor. I think that's something that up till like now and increasing like that it's frustrating for architects because we want to do something different with every project. You know, we're like sort of combining performant aspects in a different way according to whether it's like impacting, you know, some sort of performance metric or an aesthetic opportunity that exists because of the site, or something that's really important to the client or the culture, you know. And so every building is different, and so we're like bringing together these tools in a different way, and these one package CAD systems up till now, like they're really just not working for architects, which is why we see like, you know, at Foster's are using 10 or 12 different pieces of software just for one building, just for the design process, let alone all the engineering calculations.
Excellent.
Claudia, did you want to add to this, or do we have some questions from the audience actually?
Yeah, we do. Yeah.
There are some really interesting questions. I think maybe the next one could be for Shada. Okay, one is kind of obvious. Has your work been published? So I can share in the chat a link to one of the papers that has already been published, and then the other one is being reviewed, right?
Yeah, so we have a journal article in automation and construction that's been accepted. It'll be coming out soon. And there's a journal at ISARC 2020, conference.
And then there's another question for you. Ms. Shada's work on algorithmic design for dwelling units is great. I'd say it definitely is sustainable, but how well would it fare in terms of architectural value? Do you need clarification for that, or is this question clear?
I'm just going to take a stab at it. Obviously, architectural value could have so many different aspects, right? I'm an architect first, more than anything. So I'm a believer that any of these tools that they're exploratory, they're not restrictive. They're there to tell the architect and guide them and what the implications of their design is. But at the end of the day, people are going to be living in these buildings. So that's the most important thing to keep in mind. There's some quantitative things that we can consider. So for example, daylight. With extensions, the first thing that people ask is what about daylight? Is it going to be affected? So that's a big factor that needs to be analyzed in the process. So that is a problem that needs to be addressed. In terms of natural ventilation and how deep these units can get, something that I just want to mention is that when we're dealing with existing buildings, they're usually not as deep as current standards are set. So for example, the Ken Sobel Tower, the entire floor plate is around 480 square meters, if I'm not wrong. And the standard floor plate right now in Ontario is 750 square meters. So so that expansion needs to obviously happen within set zoning laws, but also the depth of these plates, there's a lot we could do with them. I hope that answered the question.
Great, thank you. There's another one for Terry about biophilic design. And the author of the question says, biophilic design would definitely work well, but many other concepts of vertical hospitality have been more about luxury than sustainability. What are your comments on this?
Well, I've recently been doing some research on biophilic design, and I often start with saying it's more than just plants. There are so many aspects to biophilic design: long views, natural materials, spatial variety, proportion of spaces. There are 14 patterns identified by researchers and loads more identified in specific projects. So their biophilic design can be used for good and for not good, I suppose. So it's sort of a set of strategies and ideas. So it can work very well with sustainability, I would say, of course, especially visual and non-visual connection to nature and for example, for stormwater management. But biophilic design is not necessarily a sustainability strategy. So I think there's like more discussion about how it's used and what it's for. But I think that biophilic design, which kind of simply put is people's natural affinity for other forms of life. People like things that grow. We like multi-sensory experiences. This can work very well with sustainability. I've studied it in learning spaces. There's like evidence showing that biophilic spaces that incorporate some of these really create a less stressful and restorative environment where people can learn and remember things better. So I think there's a lot to talk about in terms of biophilic design and sustainability. And I think as it becomes part of the well building standard, as we start to have tools like Alpha to actually, it's the first time we can predict circadian lighting performance in buildings, which is fantastic. Great plugin for Rhino. It's early stage tool. I'm using it with my students. So I think we're starting to work towards this. And I think that might be associated with luxury because we tend to implement these in more expensive properties, perhaps just like sustainability, right? Like, yeah.
It's difficult to find budget for those things and kind of like prove to the client that it's worth investing in it, right? You mentioned, I really liked in your presentation the office that is installing weather stations. And could you expand on? Do you know maybe what's the cost of that, and for what's the time span that they have to do that? And are they implementing, like you said, like a few projects? But is it something that could be scaled, like that other architectural office could also implement it in their practice, or is it another example of something being very expensive and accessible only to a certain group of clients, right?
I think it depends on what kind of weather station you want. There's probably some of us here who have Googled how much it would cost to put a little weather station on the roof. Anyone willing to admit to that? I've done it. For $500, I could get one that like is good. Like it does what I want. It depends how you want to collect the data. I kind of want it to push to my phone. Like I want to know what's happening when I'm not there. So it depends what you want. It depends how you want to store the data. Time steps is a huge issue. You're collecting loads of different data at different time steps. Are you going to be able to interpret that? But there's good, if you Google how to make a weather station on my roof, low cost, you'll find it. But for Kieran Timberlake, it was actually, I was a bit surprised that they said in their 10 most recent projects, they're installing weather stations on site. And this was in 2016, I want to say.
Oh, wow. Okay.
Last time, 17, Brady? I'm not sure when we last interviewed them. So anyway, it's probably increased, right? I mean, but they're really focused on collecting data from the building, not data from the area.
Is that before construction, like before designing? Before, yeah.
To inform the early stage design simulations. And I had a student at Ryerson this term that was using, trying to use custom skies in his daylight simulation. So there's an interest. It's sort of part of this quantified self movement of trying to collect really personal, specific microclimate data about your environment or about yourself and your activities. I think it's a direction that a lot of people are very curious about. What's the difference between a customized sky in your daylight simulation and just using a regular preset input in your climate studio or whatever. So.
And for the biophilic design, is it absolutely necessary to, measure that data, continuously? Do you have to, equip your building with a lot of sensor basically, or not necessarily? In order to create that kind of like biophilic environment, right?
It depends what you're trying to create. Like if you're measuring daylight, for example, you could do spot measurements, or you could do, you could collect data over time. It's tricky, but people are doing it. For circadian lighting, there are lots of examples of offices and other places installing a circadian system, like Arup Toronto has been doing that. So I think there's different ways. Censoring an environment and then collecting data over time is a great way to do it, especially combined with asking occupants and doing spot measurements to make sure you're on track.
Great,
All
thank
right.
you. I don't want to,
Questions?
yeah, and more questions. And there are some interesting ones for timber industry. So I'm going to start with an easy one. There's a shortage of engineered wood these days. Why?
Shortage of engineered wood. Are you referring to the types, certain types of engineered wood, or are you referring to the quantity of engineered wood? I'm assuming the latter.
Let's assume that maybe, yeah, because we don't have a way of asking a follow-up question.
Well, there are in some areas, and it, you know, it's as ridiculous as it is to say, with COVID, people are using certain wood products to do things around their home. So that has created an enormous demand on certain products. Like it's, you know, for the longest time, you know, here in Ontario, you couldn't find any pressure treated wood because people were using it to build decks on their home and those sorts of things. But in the industry generally, we're not finding that's the case. You know, there's no limit on the forestry supply. There's, you know, the same sort of manufacturers. There's a limit on, because of COVID, on the number of workers that are working in these factories. So I'm sure that has some impact. But you know, whatever shortage we're experiencing now in the industry is likely very temporary. There's nothing, you know, seriously going on that's going to limit that going forward.
And going back a little bit to digital design tools and data, is your factory going to be equipped with like log computer tomography or for example, digital wood processing, or using kind of algorithmic processes to scan and determine the most profitable breakup of a log? Are you doing this in your, and how are you managing waste then?
Yeah, absolutely. So, you know, what sort of alluded to that in the presentation a little bit. So, you know, when we're doing our detailed design for manufacturing modeling, right, we're figuring out, like, does it make the most sense to break up, you know, the CLT floor in this panel arrangement? You know, if we do it in a different way, are we able to potentially reduce, you know, the amount of wood, the thickness of the panels? If we change the panelization this way, you know, based on the CNC that we have to cut out for this mechanical opening, are we able to do it in less panels, or do we have to do it in more panels if we do it the other way? So all of that is happening at the design coordination phase. And then we're doing all that sort of modeling in softwares like Rhino, Grasshopper, and then the final model is done in CADWorks. And that is what gets sent to our factory where it's more or less just hitting print. Sorry, the guy at the factory is going to hate me for saying that, but you know, we take the CADWorks model, we hit print, and then that gets translated into data that goes into our CNC machine, so that all that is cut, you know, as was intended in the model, so that the waste is as reduced as possible, so that it's exactly what we intended it to be.
Excellent.
Hopefully that answers your question.
Curious on the topic of waste. Shada, from your research, were you measuring the amount of waste or in the renovations of these projects? Was that a metric that you were tracking in your design options?
So we did not look at that, but it is definitely doable. There are metrics popping up now. One-click LCA that Tristan mentioned. We have circularity measures they've been around for companies measuring how circular business is. We're now looking at quantifying how circular a design can be. So like if you're using wood versus concrete versus what kind of joints you're putting in, putting all that data and quantifying it gives you a circularity score of how much of your building, for example, can be looped back into. So it's definitely something that we would want to look at in the future.
Excellent. Yeah, I'm speaking about coming full circle. Just interested on, Terry, you mentioned in your talk about post-occupancy, and even it's come up a few times about comparing design simulation to what actual operation performance is. And if those studies are occurring and anyone knows, you know, if there are any studies out there that are comparing what has been simulated versus what operational energy usages are and so forth.
I think that's I think that that data is sometimes collected and less often published. So I don't have a lot of examples of that. And sort of relating to that is sort of the, like, obviously thinking about performance gaps and thinking about that gap that we have between how you simulated something would perform, and then you go and you get the energy bills and you're like, what's going on? So I've written about the performance gaps, and they're not always necessarily, for one thing, maybe it's a little bit theoretical, but there are many kinds of gaps, right? It's not just the energy gap, and sometimes it's not always negative. It's just discrepancies in how you imagined, and things change during the process and how something works. But I do think the occupant and the user plays a big role in that, like how we use buildings once we have them. Sometimes at the beginning, it's a renovation for a project, and then actually in the new building you have double the staff because it took the 2 years. You designed it for a certain number of people, the renovation happens and more people move in than you thought were going to move in. It's like, oh, well, that's one of the reasons for the discrepancy between how you thought and how it works. So I'm working on a pre and post occupancy evaluation of a hospital building in Ontario, looking at the comparison between, a little farther back, actually the architect's intentions, what gets designed, the simulations, and then in a year's time we'll be actually doing some on-site testing and some interviews with people about how the building works. And I think there aren't that many examples of that. You would think that's kind of common, especially for such an expensive health building where they're already putting so much commitment of time and resources and money. But I think that's a really interesting direction for projects to take, and maybe partnering with academia. Maybe academia can provide some of the time that maybe can't be found in a typical contract, where the architects don't really, or whoever, nobody really has the job of carrying out that comparison between simulation and actual,
Right.
that I'm aware of. Everyone we interviewed said they didn't have a method of carrying out consistent post-occupancy evaluations for every project. Nobody that we saw was doing that consistently. But I'd love to hear from others if they know of projects.
Unfortunately, no. I was going to say, sort of to your point, it's a massive sort of contractual gap that exists, and there's a lot of even some trepidation about doing that retroactive look, because it's like, what if the answer is bad? It'll help you learn a lot.
Probably going to be. It's probably going to be bad, or at least a little. Yeah.
No, it's. And I think to your point, the simulation gap sort of looked at, it's like, oh, we had this number and then we got this number and they don't match. And that was sort of the end. It was like, and it happened 150 times. So across lead projects. And that was kind of the end of talking about that one. So I think you're right. Like reconciling what's going on in the real world, and you can simulate the real world. Digital twinning is definitely rise as a method for ongoing operations and maintenance and keeping that energy bill down, and model-based commissioning and whatnot. But yeah, in terms of that reconciling between design and operation, it's a big gap, and one that I think closing is imperative for everyone.
But also touching on that, what you mentioned, Terry, the discrepancy between simulated kind of unexpected, like the behavior and what happens in the future. For example, different occupancies. Is adaptive architecture, like architecture that can change its shape, something that is a direction that is worthwhile exploring? Maybe Brady, you could start or to touch on this.
Hey, Patrick, thanks. Adaptive architecture is certainly an idea that has intrigued architects for forever, and certainly was a topic that we were like actively looking into, at the SMG during the period I was there. For instance, we were looking into multiple collaborations with the artist and engineer Chuck Hoberman. So Chuck Hoberman is famous for designing children's toys that sort of can expand and contract based on a complicated set of linkages. And he was interested in moving this to an architectural scale. And of course, this is an idea that fascinates architects. I mean, this is like very exciting Maybe like, you can see that's like an archigram, the moving cities, and Cedric Price's, ideas about these like changing environments and so forth. And so this is certainly like an idea that's captured architects' imaginations, and we're certainly actively looking into this and designing buildings that can adapt. However, the operational costs and the fabrication costs of these types of structures are often prohibitive, and also like the environmental conditions in which they have to operate. Whether it's like a super hot, dry, dusty climate or a super cold climate, that the maintenance and so forth is very it becomes a huge issue. So there are always parts of buildings that move, right, in some sort of way. There's like doors and panels and these things. And so I think there's like, how do we sort of extend these ideas realistically, to make buildings that adapt? Because there certainly is opportunity there with both adapting to sort of changing environmental considerations. I mean, we live in a climate that has different summer and winter or night and day conditions. And so we're always looking to have buildings that can change for that, but also like programmatically, as buildings change, during the day from one use to another, can we have buildings that adapt? And so I think these are certainly issues that are worth looking into, but that come at a cost, and that we have to be aware of that and not naive in our approaches to designing those.
Awesome, thank you.
Probably have time for one more question.
Yes.
So for Element 5's team, have you guys explored bringing complex geometry designs to mass timber buildings? Is it something that this market demands? What are the main challenges?
I'll leave that one to Nick.
Of course, it's certainly something that we're interested in exploring. I think the challenge really becomes getting a mass timber expert involved early, right? There are some, unfortunately, someone once told me that if you can design a concrete panel to transfer load, it's totally possible to do anything in concrete, and it's kind of true. If you can just throw as much rebar and concrete in there, you can get incredibly complicated shapes. But there are limitations to mass timber, and so if we're looking to create intense, complicated geometry, then bringing a mass timber expert on early to understand what those limitations are and then to work within those limitations is absolutely critical. We are exploring at Element 5 the use of parametric modeling and evolutionary algorithms to try and create more complicated structures and more optimized structures. We're looking at figuring out ways that we can help architects start from a very good foundation before moving potentially too far outside of the realm of what mass timber can do. But at the same time, we're also still a startup, and our first factory is coming online this year. So there's only so much that we've been able to get done at this point, but that is something we're looking to explore.
Great answer. Thank you so much. Thanks for the discussion. I would like to wrap it up with one last question for everyone. So if you were to give one practical takeaway to our audience to better design the building, what would it be? Just one. Starting with Brady, and then moving in the order of. Okay, so I'm sorry, Brady. I did
switch it up.
I did it accidentally.
I can start. Well, sure. I think my takeaway would be, or my advice perhaps to do with the design technology is that we don't have to be the victim. We're not at the mercy of design tools. We can in fact become the author and create our own design tools. And I think that's an attitude we should be taking forward. Rather than sort of throwing our hands up in the air, use these sort of questions that we have about our design. This is something that served me well in my career. When I come up against a problem designing a building, man, this takes too long to figure out. There must be a better way. If you get that there must be a better way thing, then it's up to you to innovate that better way.
Great, thank you.
That's a good one.
Terry?
That's a good question. I would say maybe that there's something in design education called in education in design tools in this area called a credibility gap. And it's the credibility gap is when you do, for example, a daylight simulation and you get an answer and you think, huh, that must be right. I got it from my simulation. And you base your answers on that and you go, I think it would be like to try to try to develop an intuition for what kinds of answers you might be creating. So with my students, we do physical measurements and we do simulations. We try to get an intuition for, like, does anyone here know what a space that's 300 SDA feels like? No, nobody can get an intuition for an annual metric of a daylit space. Not possible. But they might be able to get an intuition of what 300 lux feels like versus 100 lux on a handheld meter. So I would say don't blindly trust the simulation results or the results that your computer is telling you. Try to find a way of connecting it to your own experience, whether it's, I just wrote a paper about how smartphone daylight meters don't work, so maybe don't do that. But try to visit buildings and develop your ideas, connect the digital to the physical, I guess is what I'm trying to say, because we can't always blindly trust the results our computers are giving us. Because interpreting it is the whole battle, right? Is how do you interpret these results? That's my thoughts.
I love it. Thank you.
Yeah,
Tristan?
Yeah, I'd say ask the right questions, or specifically ask very targeted questions of your simulation team. A lot of, the very vague and long-winded answers that have come out of asking energy modelers, what does the model say? Is because that's not really a useful question. What is the impact on overhang depth and the ability to eliminate cooling in the shop? That's a strict question. We can build a rig for it very quickly, simulate and answer. And ultimately, the evolution of a design is just a series of thousands of those questions. So if we can parse them into little things that we can quickly ask and query with a simulation, then it becomes a lot more useful and cooperative design process that can, get us where we need to go.
Awesome. Shada?
I'd just like to add to all the comments and just say that validation is really important, to Terry's point and to Tristan's point specifically. Validating the results that you get within your environment or using multiple tools to find the variations between the tools, how precise they are. Doing case studies as part of schoolwork or in practice is really important. There are a lot of data for existing buildings, for example, that are public that can be used in modeling to validate what you're looking at. So I think validation is the most important, I would say.
Thank you. Patrick?
Yeah, so, this topic is about design in reference to environmental benefits. So as you can imagine, I'm going to say, think about building with wood rather than concrete or steel, obviously. So, but, one of the challenges we face in our industry is, there's a lot of interest in building in mass timber. And 95% of the projects that we're involved in come to us in not designed in mass timber. They come to us in concrete and steel. And somebody says, here's a design. What's this going to cost me in wood? If you really want to take advantage of wood as a structural element, it's really important to engage your manufacturer as early into the design process as possible. So, every manufacturer can make panels to certain sizes, and every manufacturer is different. So the design really needs, if you choose your supplier early, the design needs to be optimized for what can be produced in the factory. And ideally, what you want to do for environmental benefit is to reduce the amount of waste that you're going to get with those. So you want to utilize as close to 100% of the standard billet sizes that each manufacturer is going to make.
Thank you. Nick?
Yeah, I would say, adding to everybody's point, I think the one thing that it would be good to take away from this is just continual learning and also strive for continuous improvement. We had the initial question of whether or not we had infinite resources, what would be the target? If the target is still to, achieve net zero, and we, implement everything that we talked about today, design every building and build it in mass timber, we're still not there, right? We still don't achieve net zero yet. We don't, Tristan alluded to this, we don't have a cookie cutter solution yet for net zero. So even if we implement all these things that are, that we've talked about, that are all great ideas, we still have a long ways to go. And so I think just the, implementing of what we know, testing, validating, and making sure that then we learn from that and improve upon it and figure out what the next step is to make sure we hit the goals, I think is incredibly important to not lose sight of. Because once we hit net zero, the United Nations says we have to start looking at, carbon capture. So eventually you got to get to a point where you're not just, building at net zero, but you're also sucking stuff out of the air. So there's a long way to go, and we got to keep learning to get there.
Great. Thank you, everyone.
Really
And I guess we could add to it, or I think Terry alluded in it, like the post-occupancy studies, and that no one wants to share them. I think maybe more of like collaboration and collective effort amongst the designers, architects, engineers, builders, to actually strive for the better.
Thank you.
Thanks, everyone. Bye.
Thanks, everybody.
Thank you.
Bye for now.
Bye, everyone.
Thanks.